on the second slide anyways. So my talk is about the idea of supersizing a Ruby app. So when I got hired at Mosaic, which was only in January of this year, I was tasked to make this system go much bigger than it currently can do. So I was hired as the enterprise application architect. I'm one of four. I'm not the only one, so we work as a team. The companies that I've worked for before have all been focused around, this is the first major corporation that I've ever worked for. Usually they're small, little startups. I worked for Bowden previously to working at this company, so Bowden can vouch for what I can and cannot do. I refuse to believe that technology is not capable of doing something that somebody asked me to do. When a boss asks me, this is what I want to happen, I very, very rarely ever tell them no. That's usually a go-to for a lot of people that's been doing this for as long as I have. It's like, no, you can't do that. I try to think outside the box and go, yes, okay, give me a few minutes, give me a few days, we'll figure out how to make this work. And we usually figure out how to make this work. So I'm not a big fan of saying no. Technology is capable of doing it, just maybe not necessarily the way you've been doing it all along. I'm not a senior Ruby programmer. I know I'm giving a Ruby talk right now, but I'm not a senior Ruby programmer. I've been doing Ruby for, I would say, a little over a year. I'm an intermediate Ruby programmer at best. I have been a solutions architect and an application architect now for 7 years. I'm a coder by heart, but in the last few years, I've been sort of getting away from the coding and moving more into design. Ruby on Rails has sort of been this magical language, this magical platform that I've been trying to stay away from because I'm not a big fan of magic. However, when I took the job at Mosaic, I decided that, okay, let's figure out how this thing works and let's figure out how we can make this thing scale. As you can see, I've moved around to many, many languages. This is a small list of what they were, but it's pretty much in order. I work for a company called InstaClick. How many people here work for InstaClick? Really, just one? Wow. There's got to be more people that's worked at InstaClick. Maybe you guys are just not admitting it.
Are there any other PHP programmers here because they all work for it?
Yeah, that's entirely possible. So InstaClick was one of the more unique places that I've ever worked in that we literally had an unlimited budget. That is the strangest thing to be able to say, but we did. And I learned that an unlimited budget is an impossible way to manage getting any project done. But we did. They stupid amounts of time. So I'm going to start now. The poster boy for Ruby on Rails has always been Twitter. Everybody knows who Twitter is. They're still the biggest poster boy, but the rumor has it, and if anybody's done any research on them, Twitter has moved off of Ruby on Rails and into a different language. They moved to Scala. So why did they do this? When did they do this? They did this when they started reaching 100,000 concurrent users. When they hit 100,000 concurrent users, they reached what they believed to be the limit of what Ruby on Rails was capable of doing. So they moved to Scala. Scala runs on the JVM for better performance, and they use JavaScript in their front end for better templating speed. So I want to quickly look at the fact that this is not an anti-Ruby on Rails talk, because I'm not a big fan of Ruby on Rails, but I'm beginning to love it. But the fact is that unless your application is going to more than 100,000 concurrent users, Twitter has already proved that it's capable of handling it. So let's deal with the applications that's dealing with less than 100,000 concurrent users. That means the number of people hitting your app at the same time, okay? Which is probably most of the people in this room. So my first look into Ruby on Rails, the thing that Trevor there is crossing his arms right now because we've had many conversations on this, is Active Record. Active Record was my biggest nemesis. Active Record is an ORM, and it's a pretty advanced one for what I'm doing. ORMs is a object relational mapping, and lots of languages use them. Java uses them in Hibernate. There's a peach we wanted, I forget what the peach one was called, but they're really popular. And the thing about the ORM is that it's really, really good. The programmers get to deal with their programming and their object-oriented programming. They don't have to deal with the database. That's just all magical, and it happened outside the thing. It allows the system to easily run different databases in a production versus development environment, and you don't even stop to one development. You can make a few switches in the back end, and it suddenly switches from MS SQL to MySQL to Postgres. It doesn't really matter. The application does not care what its data source is, and that's one of the magics of Active Record. The problem is that sort of convenience comes with an awful lot of overhead, and so that's clearly why my first target is this huge, massive overhead. Scalability and overhead are natural enemies. So I have this picture here, and this picture I actually found it. I put the link to where I found it. I did not generate this picture myself. This picture is a class diagram of all the different classes on Ruby on Rails that gets instantiated as soon as you hit a .new object. So if you create a Ruby on Rails object and you say, give me an object .new, this diagram right here will show you all of the classes that you are currently loading into RAM right now, which is why I hate this guy. This is what it looks like when you do a dot first. And this is what it looks like when you do a dot all. Convenience comes with a price, and this is taking up an awful lot of overhead. So those of you who are fans of Active Record, just remember all of the stuff that you are currently loading into RAM, and remember what it's doing to your program at the time. So the pros and cons of using Active Record is the pros again is the active database layer is completely abstract. You don't really have to think about it. The application doesn't rely on any specific data source. You can freely go back and forth between them depending on whoever your DBA is for that week. And it's a short learning curve. It's actually really easy to learn how to interact with your data, which is awesome. But the magic behind this ORM is very heavy, and you've got a lot of overhead, and it's going to slow you down. There is no doubt about it. This is going to slow down your program. Here's another problem with Active Record. This is an N+1 problem, and I promise this in the next slide will be the only bits of code that I have on here. Okay? This particular piece of code, when it's written like this, will actually execute 11 queries into your database. With a small change to this, it will actually change your 11 executed data into 2 queries. So it only connects twice to this one. So I'm going to go back just to show you the difference. It's very, very small, and this is an easy error to make. But this is one of the reasons why Active Record is so dangerous. So fixing these tiny little bits of pieces in your code will actually speed up your application considerably. But after 4 or 5 months of banging my head against all of these different things and digging through the code and trying to make it a little bit better and a little bit better here and saying this is not going to scale and this is not going to scale, I come to learn one very, very important thing. It didn't matter. The way Ruby on Rails is designed, it does not matter how good or bad your code actually is. Ruby on Rails is going to scale anyways. That's one of the reasons why everybody uses it, is because the scalability of Ruby on Rails it takes care of everything. Ruby on Rails will scale as far as you have the money to buy servers. The Ruby on Rails saying servers are cheaper than developers. We don't have to spend any time making our code better. We just throw up more servers and it will just scale. So why is scaling an issue? Why did Twitter leave Ruby on Rails? So let's take the worst possible Ruby on Rails application. Okay, this entire server, the entire app can only handle 1 concurrent user, just 1. I can scale it to 1 million concurrent users by adding 1 million servers. So why didn't Twitter just add more servers? Why did they leave Ruby on Rails? Why didn't they just add more servers? They had money. They could have paid the developers, they could have done whatever they wanted. Why didn't they just add more servers? Because that's not the problem. The problem with Ruby on Rails has nothing to do with Ruby on Rails. The problem with Ruby on Rails scaling has to do with the data model and the data access. And that's where the entire problem is. And if you're looking to try to scale your Ruby on Rails application, you have to look past the application and look at your data model. Because that is 99.9% of the time, that is going to be your problem. So I have a few solutions. When we finally discovered what is the actual problem, and what is it that we're dealing with, and where's my scale issues? The read-write solution that I'm referring to. Setting your database up with a single data access point, which is how most applications are going to run. Even if you have 1 million servers, they're all talking to one database. Your data pool is only going to be, let's say, 1,500, 2,000 possible connections. That's as much as you're ever going to get concurrently. That's it. You can have as many servers as you want. There's only one data access point, and that's your limit. But as soon as you set up a master-slave relationship between multiple databases, and you read from the slaves, and you write to the master, you've now immediately, in about 45 minutes, if you pull in the right gems, you've now doubled your scalability immediately. That's a 45 immediate, low-hanging fruit solution. As soon as you scale that and add multiple slaves, you have now expanded your ability to connect to your database as far as you can still add slaves to that database. That is an immediate win. That makes you a rock star. Everybody loves you. The only caveat to this is the So, as the application scales, you can add more slave databases and expand as far as you want. Here's the problem. There is a very small window, and it depends on your configuration, between replication. So as soon as you write to the master, and it's got a replicated slide, that connection can take sometimes up to a second or two. A second or two is a problem. A second or two is a big deal when you're dealing with a massive system. So there's two ways that you can look into that solution. One of them is to add some caching. As soon as you write, make sure that you're updating the cache. The other one is to make sure that your connection, after you write, you always read from the master again, and make sure that that connection stays solid. So every time you write, you now read from the master for the rest of the execution. There's two ways of handling this. I'll say it again. One is to make sure that your caching is very good and updated after you make a write. And the other one is to make sure that you change your connection from reading from the slave to reading from the data, reading from the master, as soon as you make a write. And then your speed will increase exponentially. Sometimes read and write, though, still has its limits. Sometimes you're reading or you're writing a lot more than you can possibly handle. So we're going to take it to another level. And this is the level which we are currently doing in our company. And that's to extract your application into individual autonomous services. Each individual service can be expanded as it's needed to be expanded. Sometimes it's put on a cloud, sometimes it's however your configuration is done. These are usually REST-based. The SOAP-based stuff is so 5 years ago, 10 years ago. It allows us to access memcache a whole lot easier. We've got access to everything. And it allows you to take a look at your application, see what services are being used more often than others, and scale those guys. So we can put multiple layers of load balancers behind each of these things and scale individual services. You now have the ability, using these techniques, to actually scale your Ruby on Rails application, well, at least to the 100,000 concurrent user mark, which is what we're kind of looking for right now. Here's a diagram that shows how I am currently proposing for our company to set up their system. It puts our app servers behind the load balancers, and the app servers are calling the services through another set of load balancers. We have multiple languages. One of the benefits of having a service-oriented architecture means that not everything has to be in the same language. your services can be written in any language, and as long as the interface is kept standard, it doesn't matter from the calling application, it doesn't matter what language it's being written in. It can be written in Go, JavaScript, .NET, Ruby, JRuby, anything you want it to. This gives you the ability to put all kinds of caching in place. It gives you the ability to abstract all of your databases. Everything is now separated, and you can scale them individually. You're not stuck with trying to scale the entire app. You're scaling individual services. So in conclusion, if you have unlimited money, don't worry about your Ruby on Rails app. Just add some more servers. Focus on the data model. That's where you need to be focusing. It's not your app. You guys are probably amazing coders. It's probably not that. Talk to your DBAs. And you guys who are DBAs, it's not that it's you. It's just that maybe you guys need to talk a little bit more with the Ruby coders. If you need to cut down on the hardware budget, continue refining your use of active record. Look through the code. See if you can find some of these N+1 errors. See how you're using active record, and make sure that this is the right way to do. You know, if you decided that you wanted to go for an SQL, a direct SQL query instead of using active record, it's not necessarily a bad thing, but it's also not necessarily the right answer across the entire application. Maybe some of it is good to use active record, and some of it is good for using an SQL. Active record is not really good for complex joins. So maybe your complex object that you're trying to do, you can write those guys by hand and use the active record on where it's really good. So you get the best part of everything. I wanted to speak a little bit more about Data Mapper, but we're not actually using it, but I've heard a lot of really good things about it. So if anybody has actually used it, I wouldn't mind having a conversation with you, because I'd really be interested in learning more about it. And that's all I got. Thank you. Is there any questions? Questions about it? Okay. Our current stack, we're currently using Postgres, but due to the fact that we're a very large organization and the CTO is a big Microsoft person, we're actually moving over to MySQL. Which is good, because most of the stuff that we've written is an active record, and we can just switch it over. Anything else? Okay.
What tools do you use to, I guess, pinpoint where the scalability issues are?
What tools can we use? Well, one of the things that I use, actually, it's really good. What's the question? Schema Spy. I used an open source script called Schema Spy. And Schema Spy actually went through, and it's like Doxygen for databases. Schema Spy actually drew out my entire data model. It took about 15 minutes to configure, and then when it ran, it was the most amazing thing I'd ever seen in my life, and it drew out the entire data model. That was one of the biggest pinpoints to show me some of the data model issues that was running. Between Schema Spy and JMeter are the two things that was used to help identify some of the biggest pain points.
Any other questions?
Well, it seems to me that the whole active record issue is really that it's too general purpose, and that maybe some programming effort creating an ORM that talks directly to, let's say, Postgres, for example, might be a better impedance match for the project if you're working on it.
Well, that's entirely possible, but the problem is that most ORMs are actually designed for a one-to-one relationship between the objects and the tables. And trying to configure those things to work properly it's not a relational database problem. As soon as you get into complex objects that require multiple tables and multiple joins, ORM breaks down in every language. It's not an ORM, it's not an active record problem, it's an ORM issue. And this is the problem no matter who you talk to. So when you get into the complex objects, and that's where the problem is. That's where you start really seeing the problems with it.
Yeah, but what you're really saying is that relational databases are not a good fit for your data model.
No, relational databases are amazing for it. The overhead from an ORM and a relational data structure, when it gets really complicated, is where the bad mix is. And it's not that it's necessarily a bad thing, but when you're looking at scalability, they're not really compatible, and you need to start looking at other options. Data Mapper, as I understand it, and now I'm talking in an area that I don't know. Data Mapper is actually apparently much better at focusing on those specific relationships, but Active Record was not designed for that.
Yeah. I've been looking at Data Mapper myself as a possible alternative to Active Record and Arrow, but I'm also looking at other database scenarios such as a graph database as opposed to a relational database for the types of data that they offer.
I've also looked at other types of databases and other types of things for some of the more complex projects that we've worked in, stuff like three-dimensional databases instead of just two-dimensional databases, because of those, relational databases don't necessarily cover all of the problems in the world now. Our data and our needs and our applications are getting considerably more complex now, and maybe the databases of the 1990s are coming to their logical end.
Any other questions?
I think that's it. So thank you, guys.
Thank you.